Hey guys, Miss Gosling here. In this video, you're going to learn about the gravitational potential. By the end of the video, you'll be able to solve problems involving gravitational potentials and potential energies. So I'll be bringing back some stuff from last year that you guys hopefully remember. So the gravitational potential is calculated at a specific point in space. So the gravitational potential on the top of Mount Everest is going to be different than the gravitational potential here at sea level, which will be different than the gravitational potential calculated out in orbit. And we define the gravitational potential as the amount of work needed to bring 1 unit of mass, usually 1 kilogram, from infinity to that point in space. So essentially what we're doing is we're bringing something from a place with 0 potential energy to the point in space that we are interested in. And so we define our gravitational potential, V sub g, as the work, W, per unit divided by the amount of mass that we are bringing to that position in space. This, again, the amount of work needed to bring 1 kilogram to some specific spot in the universe. So before I actually get into the gravitational potential equation and all of that, I do want to just remind you of the relationship between gravitational force and gravitational field. So our gravitational force equation, gmm over r squared, in that equation, we define gm divided by r squared as little g, giving us our gravitational field, which gives us that our force is actually equal to our field times our mass. And so the gravitational field is useful because if we know our field at any position in space, then all we have to do is we can put any mass at that point in space and know immediately what force it feels. So as you guys probably remember, it's a lot easier to calculate your weight on Earth than it is on Mars, because we know that on Earth, little g is negative 9.8 meters per second squared, or negative 9.8 newtons per kilogram. While on Mars, we have to go through this whole rigmarole of calculating our force, given the mass of the planet and the mass of our object. So the gravitational potential is essentially analogous to our gravitational field. It's useful because if we know our gravitational potential, V sub g, it's very easy for us to calculate our potential energy at a given point in space. So reminding you of our unit on energy, we define our gravitational potential energy as mass times the gravitational field, little g, which is of course gm over r squared, divided by our distance r from the surface of, or from the surface of in that unit from the surface of the Earth. So another way to write our gravitational potential is gmm over r, or the gravitational constant times the mass of the planet times the mass of the object divided by how far we are from the kind of center of mass of the planet. And just as we define little g, our gravitational field, as the gravitational force divided by the mass of the object that we put in, we define our gravitational potential as our gravitational potential energy divided by mass. So in this case, our gravitational potential is given by g, 6.67 times 10 to the negative 11th, times the mass of the object creating the gravitational field or the gravitational potential. So usually that's some sort of a planet, divided by our distance from the center of mass of the planet. And so the only difference that we can see between our gravitational potential equation and our gravitational field equation is that instead of dividing by r squared, we're just dividing by r. And given our gravitational potential, we can multiply our potential by the mass of the object we're placing at that point in space, and from there we get our gravitational potential energy, U sub g. So let's go ahead and do a quick example. The radius of the Earth is 6.4 megameters, or 6.4 times 10 to the 6th meters. And the mass of the Earth is 6 times 10 to the 24th kilograms. And we're going to calculate the potential at the surface of the Earth and then the gravitational potential energy of a 50 kilogram figure skater on the surface of the Earth. So for part A, we are going to use our gravitational potential equation. V sub g equals negative gm over r. Plugging in our numbers, that gives us that our gravitational potential is negative 6.67 times 10 to the negative 11th times 6 times 10 to the 24th kilograms divided by 6.4 times 10 to the 6th meters. Note that I am converting from megameters to meters. And that capital M is what gives us our 10 to the 6th. Thus, our gravitational potential is 6.3 times 10 to the 7th joules per kilogram. Joules per kilogram being, with joules being the unit the same unit that we use to measure our potential energy, and kilogram, of course, being the unit of mass. So that is part A. And calculating the gravitational potential should generally be pretty easy because a lot of it is just plugging numbers into an equation. Next, let's go ahead and calculate the gravitational potential energy of that 50 kilogram figure skater. So the hard way to do this is to use our gravitational potential energy equation. Ug equals negative gmm over r. Plugging in and that gives us, of course, negative 6.67 times 10 to the negative 11th times 6 times 10 to the 24th times 50, divided by our distance from the center of the Earth, how far we are from the center of the Earth, 6.4 times 10 to the 6th. But that's ugly, and that's so much work, and I, for one, have no interest in dealing with scientific notation in my calculator any more than I need to. So an easier way to do this is to use our alternative equation. Ug equals Vg times m. So our gravitational potential, V sub g, is 6.3 times 10 to the 7th, and the mass of our figure skater is 50 kilograms. So we multiply 6.3 times 10 to the 7th times 50, giving us a gravitational potential energy of 3.1 times 10 to the 9th joules. And there you have it. That is how we can use the gravitational potential to easily calculate the gravitational potential energy of any object given its mass. So with that, let's go ahead and talk takeaways. First of all, the gravitational potential is given by V sub g equals negative gm over r, and we can calculate gravitational potential energy by multiplying Vg by the mass of the object of interest. So with that, you now know how to use the gravitational potential. It is your turn to try solving some problems. Best of luck and happy solving.